Let's talk about a cosmic measuring stick. Imagine a ladder that doesn't just measure distance, but potential, a way to rank civilizations across the universe. Today, we're going to climb that ladder and see where we, humanity, fit into the grand scheme of things.
It all boils down to that one huge question, doesn't it? Are we alone? For as long as we've had eyes to see the stars, we've wondered if anyone else is out there looking back at us. It's probably the most fundamental question we can ask.
So for a long time, our main strategy has been, well, to listen. We've got projects like SETI, the Search for Extraterrestrial Intelligence, that have been pointing these massive radio telescopes at the sky, just hoping to catch a stray signal, some kind of deliberate hello from across the void.
But what if that's the wrong approach entirely? See, listening for whisper assumes they want to be found. A different idea is gaining ground. Instead of eavesdropping, we should be looking for lighthouses. Not messages they choose to send, but the unavoidable large-scale evidence of their technology, the stuff they just can't hide. And that idea brings us to this incredible framework put together way back in 1964 by a Soviet astrophysicist named Nikolai Kardashev. He suggested we could classify civilizations based on the one thing that is absolutely universal and essential for any species to thrive: energy consumption. So the first big step, the first rung on this cosmic ladder, is becoming a Type 1 civilization. These are the planet tamers. We're talking about a civilization that has total and complete mastery over all the energy on its home world. Think harnessing every volcano, controlling the weather, managing the entire planet as one big, efficient machine. And to put that number in perspective, that is a lot of power. A Type 1 civilization would be using something like 1,000 times more energy than our entire world does right now. Every single second, they'd be wielding the power of millions of lightning strikes. It's a lot. Okay, but mastering your home planet, that's just the beginning. The next giant leap is to become a Type 2 civilization, the Star Harvesters. These guys have moved beyond their little rock and figured out how to capture and control the entire energy output of their star. And just look at that number, 10 to the 26th watts. That is not just a step up, that is a 10 billion-fold increase over Type 1. We've gone from planetary to truly stellar power. The scale is just staggering. And then, at the top of Kardashev's original scale, you have Type 3, the galaxy shapers. This is where things get truly mind-bending. A civilization so advanced it can harness the energy of its entire home galaxy. Every single star, maybe even the supermassive black hole at the center. At this point, they're not just living in the galaxy, they are the galaxy's power plant. Okay, so with all that cosmic power in mind, where do we fit in? Well, the great astronomer Carl Sagan actually took this scale and worked out a formula to place us on it. And his result? We're a Type 0.7 civilization. Yeah, we haven't even made it to the first rung of the ladder yet. So that begs the question, right? How in the world does a civilization even begin to harness the power of an entire star? Well, that question leads us to one of the coolest, most famous big ideas in all of science and science fiction, the Dyson Sphere. Now, hold on. When you hear Dyson Sphere, you probably picture a giant, solid metal shell built all the way around a star, like you see in the movies. But the physicist who came up with it, Freeman Dyson, he said that's actually impossible. It would tear itself apart. What he really imagined was a Dyson swarm, a huge orbiting cloud of individual solar collectors, built up slowly over thousands of years. I mean, just try to wrap your head around a construction project like this. It's almost literally beyond comprehension. First, you'd need the raw materials. How about taking apart an entire planet, something like Mercury? Then you'd need a workforce, a massive fleet of self-replicating robots to do the building. And this isn't going to happen overnight. We're talking about a construction project that could last for millennia.
Okay, so if these unbelievable structures could actually exist, how on earth would we find one? This is where the hunt for techno-signatures comes in. See, a civilization can choose to be quiet, but it can't hide its giant construction projects from the laws of physics.
There are two main giveaways we could look for. First, waste heat. You can't escape thermodynamics. A Dyson swarm would soak up visible light from its star and have to radiate away all that excess energy as heat, making it glow like a Christmas tree in infrared light. Second, We could see some really weird dimming patterns as these gigantic, oddly shaped collectors pass in front of their star. And then in 2015, this whole theoretical hunt suddenly got very, very real. Astronomers spotted a star, KIC 8462852, that was acting, well, bizarre, in a way no one had ever seen before. It got the nickname Tabby Star, and for a little while there, it looked like we might have actually found something. The data that came back was just wild. The star's light was dimming by up to 22%. For context, a huge planet like Jupiter passing in front of our sun would only block about 1%. So for a moment, the alien megastructure idea was a serious possibility. But then came the key piece of evidence. The starlight was being blocked more in the blue spectrum than in the red, and that's the classic signature of fine dust, not some massive solid object. So, okay, it probably wasn't aliens building a Dyson swarm. But Tabby Star was still incredibly important. It was like a live fire drill for our detection methods. It proved that we can spot these strange anomalies out there in the cosmos, and that hunting for cosmic engineering projects is actually possible. But this brings us to a pretty sobering reality. After all this searching for both whispers and for lighthouses, the universe is, for all intents and purposes, silent. Our big surveys of the sky, looking for the telltale signs of Type 2 and Type 3 civilizations, have come up completely empty. Nothing. And that quiet just makes one of the biggest puzzles in science even deeper, the Fermi paradox. If the universe is so big and so old, where is everybody? And this is the part that's really chilling. The silence we're observing isn't just someone choosing not to pick up the phone. It's a thermodynamic silence. We don't see the enormous signatures of waste heat that a galaxy-spanning civilization should be pumping out. They can choose not to talk to us, sure, but they can't hide from physics, and that makes their absence even spookier. So let's pull all this cosmic perspective back down to Earth. What does this ladder really mean for us, for our future? What is humanity's next great step? Well, just getting to Type 1 status is the great challenge for the next few centuries. Right now, we're hovering around Type 0.73. The most optimistic projections say we can make that jump to Type 1 in maybe 1 or 200 years. More cautious models, the ones that factor in our current problems and limitations, put that date closer to the year 2371. And that leaves us with one last big thought to chew on. The whole Kardashev scale is built on the assumption that more power equals more advancement. But is that the only way forward? Could it be that true, lasting progress isn't about endless expansion, but about becoming more efficient, mastering information, or finding a sustainable balance that lets a civilization survive for millions of years? The latter is there, for sure, but whether climbing it is our ultimate destiny, well, that's a question we have to answer for ourselves.